Namaste dear students. We have started chapter number 2, Mechanical Properties of Fluids of 12th standard, and we have seen the topic surface tension, surface energy, relation between surface tension and surface energy, and we have also seen the problems which are related to those topics in lecture 1, lecture 2, 3 and 4. Now today we discuss the topic angle of contact. Now when liquid is in contact with solid, then it will form the meniscus. That meniscus may be concave or it may be convex. It will depend upon nature of the liquid and solid. Now suppose we take a kerosene. Kerosene is a liquid which will partially weight the solid. म्हणजे केरोसिन म्हणजे आपण त्याला रॉकेल म्हणतो. रॉकेल असं लिक्विड आहे की ते जर काचेमध्ये घेतलं किंवा ग्लासमध्ये घेतलं तर ते सॉलिडला पार्शियली वेट करतं, पूर्ण ओलं पण नाही करत किंवा पूर्ण कोरडंही राहू देत नाही. तर असं जर लिक्विड जर आपण घेतलं ग्लासमध्ये तर त्याचा जो मेनिस्कस असेल तर तो जो मेनिस्कस आहे तो कॉन्केव मेनिस्कस असेल. सो इफ यू टेक द लिक्विड which will partially weight the solid, the meniscus is a concave meniscus and it is shown in this figure. In this figure, liquid is a kerosene. So kerosene is a liquid which will partially weight the solid, and here this meniscus is formed. This meniscus is formed, and this meniscus is a concave meniscus. Then if you take the mercury and this mercury will form the convex meniscus. It is shown in this second figure. This is a convex meniscus. It is like this. This is a convex meniscus and this is a concave meniscus. So concave and convex meniscus are shown like this. This is a concave meniscus and this is a convex meniscus. असे हे convex आणि concave meniscus असे असतात. Then what is the angle of contact? If you draw a tangent to the surface of the liquid, if you draw the tangent to the surface of the liquid, and if you measure the angle between the tangent and the solid surface, then that angle is called the angle of contact. This angle is measured within the liquid. Means this angle should be measured within the liquid, and this angle is called the angle of contact. So angle of contact means the angle between the tangent drawn from the liquid surface and solid surface at the point of contact, and which is measured within the liquid. It is called the angle of contact. Now here in this figure, this is the angle of contact. This is tangent. This is a tangent drawn to the convex surface, and the angle between this tangent and this solid surface is called the angle of contact. So this is meaning of the angle of contact. म्हणजे सिंपल meaning आहे angle of contact चा की जर समजा आपण जर समजा अशी tangent ड्रॉ केली कर्व सरफेसला या इथून या पॉइंट ऑफ कॉन्टॅक्ट पासून, आणि ती जी टँजंट आहे ते टँजंट आणि सॉलिड सरफेस याच्यातला जो अँगल असतो हा अँगल म्हणजे अँगल ऑफ कॉन्टॅक्ट असतो. असं एक सिंपल अशी याची डेफिनेशन आहे. या फिगर मध्ये इथे अशी टँजंट ड्रॉ केली आपण समजा, आणि हा सॉलिड सरफेस आहे, तर टँजंट मधला आणि सॉलिड सरफेस मधला हा जो अँगल असेल हा अँगल ऑफ कॉन्टॅक्ट असेल. angle of contact for the concave angle of contact for the concave meniscus is acute angle of contact. It will form the acute angle of contact for the concave, and angle of contact for the convex meniscus is obtuse angle of contact. म्हणजे acute म्हणजे काय की ज्या अँगलचे मेजरमेंट हे 90 डिग्री पेक्षा कमी असतं तो acute, आणि 90 डिग्री पेक्षा जास्त असेल तर ऑब्स्ट्यूस अँगल असेल. तर जेव्हा कॉन्केव्ह असेल तर acute अँगल फॉर्म होईल, आणि जेव्हा कॉन्व्हेक्स असेल तर त्यावेळेस ऑब्स्ट्यूस अँगल तिथे फॉर्म केला जाईल. सो दिस इज डेफिनेशन, दिस इज मीनिंग ऑफ द अँगल ऑफ कॉन्टॅक्ट. नाउ लेट अस एक्सप्लेन why there is a concave meniscus and why there is a convex meniscus when liquid is in contact with the solid. Now convex and concave meniscus is only because of the adhesive force and the cohesive force which is produced between solid and liquid surface. Now let us see using this diagram. Now in this figure, this black portion is a glass material. It is a solid. This is a glass material. Then this red portion is a liquid. Liquid means it is a liquid which will partially weight the solid. म्हणजे हे kerosene liquid असेल. This is a kerosene. We have taken kerosene liquid and glass solid, and when glass and kerosene are taken, there will be the concave meniscus form. Now consider molecule A, which is on the surface of the liquid and which is in contact with the solid. हा मॉलिक्यूल एक असा आहे की लिक्विडच्या कॉन्टॅक्ट मध्ये आणि लिक्विडच्या सरफेसवर आणि सॉलिडच्या कॉन्टॅक्ट मध्ये असलेला असा हा मॉलिक्यूल घ्यायचा. देन ड्रॉ द स्फियर ऑफ इन्फ्लुएन्स सराउंडिंग मॉलिक्यूल ए in the form of the circle. Draw the sphere of influence. Then there are two forces acting on molecule A. First force is vector AP, and this vector AP force is a adhesive force. It is an adhesive force, and this adhesive force is acting horizontally, and it is shown by vector AP. Then second force acting is vector AQ, and this vector AQ force is a cohesive force, and this cohesive force is force between it is the force between the molecules of the same substance. म्हणजे A molecule हा लिक्विडचा मॉलिक्यूल आहे आणि दुसऱ्या लिक्विडच्या मॉलिक्यूल मध्ये आणि A मध्ये जो फोर्स आहे तो म्हणजे कोहेसिव्ह फोर्स आहे. आणि adhesive म्हणजे काय की the force between different molecules of the different substances. तर हा cohesive force असेल vector AQ. Now here in this figure or in this case when there is a kerosene and solid combination, means when there is a kerosene and glass combination, in this case the value of vector AP is very large as compared to vector AQ. म्हणजे हा जो फोर्स असतो adhesive force ची व्हॅल्यू cohesive force पेक्षा खूप जास्त असते. And therefore if you draw the resultant of vector AP and vector AQ, the resultant of vector AP and vector AQ is vector AR, and this vector AR lies in the solid, and vector AR lies in the solid. Now what is natural tendency of the liquid? Natural tendency of the liquid is or in the stable condition, the liquid molecule is always normal, or it is always normal to the surface. It means that the resultant of the two vectors should always normal, it should always perpendicular to the surface. This is the natural condition, or this is the equilibrium condition. We can say it is the condition of the stability. What is condition? The resultant of the two vectors should be normal to the liquid surface. It should be normal to the liquid surface. Now, liquid molecules on the surface. Now, to make this vector AR normal to the surface means to make this resultant AR normal to AT, which is the tangent, normal to the tangent, this liquid molecule A piles, means it moves in upward direction. It moves in upward direction, and because of this, the shape of the liquid near the solid, in contact with the solid, is a concave. So this is the explanation of the concave meniscus. So what is basic thing here? Basic thing is that the resultant vector AR should be perpendicular to the tangent, and to make this resultant vector AR perpendicular to the tangent, this liquid molecule A piles, or it moves in upward direction, and therefore liquid surface in contact with the solid is a concave surface, and the angle which is formed is an acute angle. म्हणजे ही जी टँजंट आहे आणि हा सॉलिड सरफेस आहे याच्यातला जो अँगल असेल हा acute angle असेल. So this is the explanation. Now let us explain convex meniscus. Now if you take the liquid which is the mercury, it will not weight the solid completely. Mercury is the liquid which will not weight the solid completely. In this case, the value of vector AQ is very large as compared to value of vector AP. Means the result because of that, the resultant vector AR, this resultant vector AR lies inside the liquid. It will lie in the liquid, and to make this resultant vector AR perpendicular to the tangent or normal to the liquid surface, this molecule A creeps. It means that the molecule A moves down. Slowly it will move down, and the convex part will be formed here. And this is the explanation of the convex meniscus. म्हणजे convex meniscus हा कसा तयार होतो की हा जो वेक्टर AQ आहे इथे, वेक्टर AQ म्हणजे कोहेसिव्ह फोर्स आहे आणि वेक्टर AP म्हणजे काय तर अधेसिव्ह फोर्स आहे. हा कोहेसिव्ह फोर्सची किंमत अधेसिव्ह फोर्स म्हणजे AQ ची किंमत AP पेक्षा खूप जास्त राहील. आणि जर समजा आपण याचा जर रिझल्टंट फाइंड केला, वेक्टर AQ आणि वेक्टर AP चा आपण रिझल्टंट जर फाइंड केला, तर याचा जो रिझल्टंट असेल हा रिझल्टंट हा लिक्विड मध्ये दिसेल किंवा इट विल कम टू द लिक्विड साइड, इनसाइड द लिक्विड. आणि मग या रिझल्टंटला टँजंट हा जो रिझल्टंट आहे सरफेसला परपेंडिक्युलर होण्यासाठी किंवा टँजंटला परपेंडिक्युलर होण्यासाठी हा जो लिक्विड मॉलिक्यूल आहे तो खाली येतो. लिक्विड मॉलिक्यूल खाली आला म्हणजे तिथे कॉन्वेक्स सरफेस हा फॉर्म होतो. आणि सो दिस इज एक्सप्लेनेशन व्हाय द कॉन्वेक्स मेनिस्कस इज फॉर्म. And this is end of today's topic. We see next topic in next lecture. Thank you very much.